Hello everybody, welcome to your 3.6. We're going to do a lot of transformations today, so get ready. Let's go to the first page. So how does the graph of the linear function f of x equals x compare to the graphs of g of x equals f of x plus c and h of x equals f times c of x? Okay, so basically what this means is you have some new function. These are new functions that equal your old function plus something, or your old function multiplied by something. Okay, that's all that goes down to. So let's just work this out. Okay, let's go to this first section here. And it says the graph of f of x equals x. So this is called, you want to highlight that, this is called the parent function. Parent function. Okay, so sketch the graph of each function along with f on the same set of coordinate axes using the graphing. We're not going to use graphing calculator. We're going to use this with our knowledge of slopes and all that good stuff. So let's just go look at this. We're going to graph in black our original function. Okay, so let me do this. Perfect. So this is my y equals x, and I'm going to make that note right here, y equals x. That's just my normal one. Now let's talk about transformations. This says, this plus 4 means we're going to go up 4. So your x-intercept, or sorry, your y-intercept is going to go up 4. This doesn't change the slope of your line or anything. Okay, so you're going to try to have, when you draw this, you're going to try to have the same exact slope as you did before. So mine's a little off here. Let's see if I can move this a little bit. I can't. So you're going to try to have it the same. Okay. This next one, you're going to have your x plus 2. So you're going to go up 2. So let's graph our old one right here. And then like this. Okay, and then we're going to do our arrows. So then now we're going to go up 2. So right here. So your new graph is going to be here. All right, we're going to add our arrows. Moving on. So let's do our original. Okay, do your arrow. So that's my y equals x, remember. Now this says we're going to move down 2. So we're going to take our y-intercept, go down 2, and then draw our line. And remember, you want to still have the same type of slope, same everything. Sometimes it's a little hard to get to when you're not having, when you don't use a table and you don't have actual points. So this one says we're going to go down 4. So we have our original here, and then we're going to draw our line. Okay, I got to make that go through the middle. There we go. And then it says we're going to go down 4, so our y-intercept is going to go down to -4, and then we're going to draw our line. And then our arrows. Okay, so that's these are vertical translations. Okay, up or down. And I want you to write this definition. F of x equals, or sorry, let's do g of x. Let's do our new function. So g of x equals your old plus c. And if c is greater than 1, you're going to go up. If c is less than 1, you're going to go down. Okay, let's now move on to some horizontal movement. So right now, let's not focus on this, is this vertical or is this a horizontal stretch or shrink? Okay, let's just talk about the numbers. Okay, so when you have a coefficient of x like this, you'll start to see that if it's like f of cx, you're going to have a horizontal stretch or shrink. Okay, we'll talk about how you do that in a minute. If you have C, f of x, you're going to have a vertical stretch or shrink. Okay, so let's not focus on determining is this horizontal or is this vertical right now. I just want you to have these definitions written down because you're going to need them a little bit later in this lesson. So let's talk about y equals mx plus b. Okay, and let's talk about how b is your y-intercept at 0, b, and then your slope is m. Okay, so first we're going to graph our parent function, which is y equals x. So let's graph that. Remember, y equals x, our parent function, goes through the origin, like so. All right, so when we have y equals x, let's talk about this real quick. We'll go down here. When I have y equals x, my slope is going to be 1 over 1, because remember, you can rewrite this as 1 over 1x. So this means you're going to go up 1 to the right 1, right? Well, I have this new one. This new function says h of x is equal to 1/2 x. So when we talk about slope-intercept form, our slope is going to be 1/2. So we're going to go up 1, right 2. So is this going to give you a steeper line, or is this going to give you a not so steep line? Well, let's talk about this. Up 1, right 1 is going to look like that, right? But if I start at 0 and I go up 1, right 2, so start at 0, go up 1, right 2, here's my other point. Up 1, right 2, here's my other point. So to go the other way, down 1, right 2, down 1, right 2, down 1, right 2, there's my line. Okay, so let's draw this line here. Let's see how accurate I get this. Pretty accurate. Perfect. So that's my y equals 1/2 x. So let me rephrase. This is 1/2 plus 0, right? So you start at 0, 0, and you move up 1, right 2. Okay, let's go to this one over here. Let's plot our original. Your parent function, remember, it goes through the x-axis, or sorry, through the origin. Okay, so we've got this going on here. And so now we have y equals 2x. So we could say this is plus 0 and change this to y. So we have our y equals mx plus b. So our y-intercept is 0, 0. So we're going to start there. And then our slope says we're going up 2 to the right 1. So we're going up 2 to the right 1. Up 2 to the right 1. To go the other way, we go down 2 to the left 1, down 2 to the left 1. And we're going to draw this line as best we can. Oh yeah, I knew that wasn't going to take. Hold on, let me try this again. Do. Yeah! All right. And draw your arrows. Okay, so are you starting to see how this is affecting the graphs a little bit? Look at these two. Analyze these two and see, okay, when I had 1/2, it became a little not so steep of my slope. Then when I had 2, my line became very steep. So let's talk about this one. We have y equals mx plus b. So this is like plus 0, so our y-intercept is 0, 0. So that's where we're going to start. Oh, you know what I forgot to do? I forgot to plot my original. Let me do that. Okay. And then let's go back to, okay, so then our slope says we're going, remember I said take the negative and take it to the top. So you're going down 1, right 2. And you're starting at 0, 0. So you're going down 1, right 2. Down 1, right 2. And we can, so then we have to go up 1, left 2. Up 1, left 2. So my line is going to look like that. Oh, that didn't work, did it? Let's try this again. Do-do-do-do-do. There we go. All right, and let's put our arrows here. Perfect. All right, so let's look at the next one. We have h of x is equal to negative 2x. So think y equals mx plus b. First, let's do our original parent function line. Do. This and this, okay? And then our slope, well, we're starting at 0, 0, right? Because it's mx plus b. Y equals mx plus b. So we're starting at 0, 0. And then this says our slope, we're going down to over 1. So down to right 1. Down to right 1. Down to right 1. So then we're going to go up to left 1. Oh, wait. Down to right 1. Down to right 1. Then we're going to go up to left 1. Up to left 1. There we go. Had it wrong there for a second. And let's draw our line here. Oops, that didn't work. Let's try this again. Draw our line. Perfect. All right. So this is us not worrying about, is this vertical, is this horizontal? I don't know. This is us using our previous knowledge of slope-intercept form and learning how to graph from there. Are you going to have to learn your transformations? Absolutely. After this, though. So let's talk about these graphs. Okay, let's talk about what's going to go on here. If I were to graph this just originally, I'm going to start at 0, negative 4, and then my slope says I'm going up to right 1. So where's that graph? I start at 0, negative 4. This is the only one that starts at 0, negative 4. And then I go up to the right 1. So this one is A. So then let's talk about this one. Slope intercept says I start at 0, 2. And I go down to the right 1. So go to 0, 2. And I go down to right 1. So this one's going to go to B. And this one, so I start at 0, 4. And I go up 1, right 2. So 0, 4. And then up 1 to the right 2. There we go. So that's C. And then let's do this last one. We start at 0, negative 2. And we go, our slope says down 1, right 2. And then so we're going to go up 1. Oh, sorry, down 1 to the right 2. So this is D. Okay, so let's talk about transformations now. Let's start working on that. Okay, so if you have g of x equals f of x plus c, so basically your new one equals your old one plus c. So this means, this means your new equals your old graph plus c. This plus c means a vertical translation, aka up or down. Okay, so this next one, same kind of thing. Here's your new. So new equals your old. And you see how there's a C on the inside? That means you're going to have multiplied by C. This means you're going to have a horizontal stretch or horizontal shrink. And how do we know the difference? Well, if your C is greater than 1, you're going to have a shrink. I don't know what happened and like messed up. So I have really no idea. It like skipped and I was like, okay. But anyway, so if c is greater than 1, it's going to be a shrink. So this needs to go here. A shrink. And then if c is less than 1, it's going to be a stretch. Okay? All right. So now that that glitch is out of the way, let's go over here. So parent function, when you're talking about linear, y is equal to x. Okay, so this means that your slope is 1 over 1 and your y-intercept is 0, 0. Okay, a transformation is some sort of movement on your graph. Okay, translation means you're going horizontally, left or right, or you're going vertically, up or down. Your reflection means you're reflecting across x-axis or reflecting across the y-axis. Okay, moving, you have a horizontal shrink. That means your graph's going to look like f of c of x, where c is greater than 1. Horizontal stretch means f of c of x, where c is less than 1. Vertical stretch is c times f of x, where c is greater than 1 for a stretch, and then c times f of x, where c is less than 1. So notice these two things are different, right? A shrink for horizontal means your c is greater than 1. But for a stretch, that means c is greater than 1 vertically. So do you see what I'm saying? So notice the difference, okay? All right. Moving on. So here is your math lingo, okay? You have a horizontal stretch or shrink. Did I skip a page? I sure did. Just kidding. You have a translation. You have horizontal and vertical movement. So your horizontal is going to be right or left. Right or left. Your vertical is going to be up or down. And these are your actual formulas. I don't expect you to memorize these, but I do expect you to understand what these mean. All right, so then let's talk about reflections. You have y equals negative f of x versus y equals f of negative x. One, you are going to reflect on the x-axis, and the other one, you're going to reflect on the y. So look how your arrows are pointing. Here's your y equals f of x, and then look how your arrows go. Okay, so that's important stuff to know. Then let's go over here to stretch and shrink. This is the hardest for people to understand because it's a little bit backwards. If you do f of c of x, or they use a, same thing, okay? If c is greater than 1, you would think it stretches, right? But it's horizontal. And remember, horizontal is always in that parenthesis stuff, and it means O for opposite. Okay, so if you think it's going to stretch, it's actually going to shrink. And if c is less than 1, you think it would shrink, but it's actually going to stretch because it's horizontal. However, that's not the same for vertical. If you have c f of x, if c is greater than 1, it's going to do the normal thing of stretching. And if c is less than 1, it's going to shrink. So horizontal is always the opposite, just like when you go left or right. If it's f of x minus h, you're going right. And if it's f of x plus h, you're going to the left. So horizontal is always opposite of what you think it would be doing. Okay? All right. So let's go over here to the practice, and then we'll be done. So you have your f of x equals 1/2 x. That's your old one. And it says your new one is taking your old one, and it's doing what? This -2 says you're going to go down 2. Okay? You have your f of x right here, and it says negative x plus 1. It's asking you what the new one's going to be doing. It's taking your old one, and because it's inside parentheses, this is going to be a horizontal translation. And we are going to be moving to the right 2. Next one, you have f of x equals 3x. There's your old one. Your new one says negative x on the inside. So this is going to be a reflection across y-axis. Then you have f of x is equal to x minus 1. Your new one says you're taking this one, and do you see how your multiplier is on the inside? So because it's in the parentheses, it's going to be horizontal, because remember, horizontal is always in parentheses, and then it's always opposite of what you think. So you're going to have some shrink or stretch, but do you see that 1/2 is less than 1? So you would think this is a shrink, but because it's horizontal, it's opposite. So it's actually going to be a stretch. All right, moving on. F of x is your original one. G of x equals 2 f of x. So the 2 is on the outside. So this is going to be a vertical stretch or shrink because it's being multiplied. But because 2 is greater than 1, it's going to be a vertical stretch. Okay. Then we have f of x equals negative x plus 2. So you have your old one, and then it says you're multiplying it by 1/2. So because that multiplying is on the outside, it's going to be vertical, stretch or shrink, and 1/2 is less than 1, so it's going to be a vertical shrink. Okay, so now graph f of x equals x, and then graph g of x equals 3x minus 2. Describe the transformations from the graph of f to the graph of g. So remember, your parent function goes through the origin at 0, 0, and your slope is up 1 over 1, up 1 over 1. So that's how you're going to draw that graph. So let's draw that first. And I got to move it up a little bit, okay? Make sure you don't forget your arrows. So now let's write our g of x equals 3x minus 2. So this means we're going to go down 2. And then you guys know how to graph this because you guys know y equals mx plus b. So this would be up 3 to the right 1. So you're going to go from 0, negative 2, because that's what this means. 0, negative 2, that's where you're going to start. And you're going to go up 3 over 1. Up 3, right 1. To go the opposite way, I'm going to go down 3, left 1. Okay, so let's draw this line. All right, and we have our arrows here. So what do you think? Is this a vertical or is this a horizontal shift? Because it's of some vertical or horizontal shift. I think personally that this would be a vertical shift. So we went down 2, and this means vertical, a vertical stretch, because 3 is greater than 1, so it's a stretch. All right, so we'll work on this more in class, but that is your 3.6. Bye.